Hello and welcome. Today, we're diving into a fascinating project, building a simple command line game where you train a virtual AI assistant. This isn't just about game development, it's a practical, hands on way to grasp the core concepts that power real world AI systems. By the end of this lesson, you'll have a much clearer understanding of how complex AI applications are structured and function. Our objectives are clear. You will learn to understand the principles of modular Python architecture, breaking down complex problems into manageable, reusable components. You'll also discover how to leverage classes to model AI agents, giving them distinct identities and capabilities. We'll explore using dictionaries as efficient knowledge stores, enabling our AI to learn and recall information effectively. Finally, you'll see how functions serve as modular behavior units, allowing our AI to perform different tasks dynamically. Let's get started and build something truly insightful. You might be thinking, a game? How does that relate to serious AI? Here's the crucial insight. Every AI system, from a simple recommendation engine to a sophisticated large language model like ChatGPT, follows the same fundamental pattern we're implementing today. It receives input, processes it through learned behaviors, and then produces an intelligent output. This core loop is universal. Our command line game serves as a simplified yet incredibly powerful analogy for this process. The logic you apply to handle user commands and update your virtual AI skills directly mirrors how real AI applications interact with data and learn over time. So when we talk about game logic, we're actually learning about the foundational principles of AI logic. These aren't just abstract programming concepts. They're the exact building blocks you'll encounter and utilize when developing robust, production-ready AI agents in the real world. Understanding this connection now will give you a significant advantage. Now, let's look at how we represent these intelligent entities. In software development, especially when building AI, we model these intelligent agents using classes. Think of a class as a blueprint, a template for creating AI agents. Each instance of this class isn't just a generic piece of code. It's a unique AI assistant with its own memory, its own set of capabilities, and its own learning progress. For example, our AI assistant class will encapsulate everything our AI knows and has experienced. This approach directly mirrors how real AI systems operate. When you interact with multiple conversations in a tool like ChatGPT, each conversation maintains its separate context, its unique memory of your interaction. That's precisely what we're achieving here. Individual training histories and distinct sets of learned skills for each AI assistant we create. This modularity is key to building scalable and understandable AI applications. Next, let's talk about how our AI agents store what they learn. AI systems require highly efficient ways to store and retrieve learned information, and Python dictionaries are perfectly suited for this. They function much like a brain's associative memory, mapping specific inputs to corresponding outputs or responses. In our simulator, the skills dictionary within our AI assistant will map skill types, like greeting or math, to a list of potential responses or learned examples. This is fundamentally similar to how neural networks map features to predictions or how recommendation systems link user preferences to items. What you're seeing in this simple dictionary isn't just a basic data structure. It's the conceptual foundation that scales up to highly complex structures in production AI, such as embedding vectors that represent words or concepts, or intricate knowledge graphs that link vast amounts of information. By organizing data intelligently, we empower our AI to respond intelligently. Finally, let's integrate these concepts into actions. Just as real AI systems are broken down into modular components, like a speech recognition module, a natural language understanding module, and a response generation module, our game uses functions to encapsulate specific behaviors. For example, our train assistant function handles the logic for teaching the AI new skills, much like updating model weights in a real AI system. This modular approach is paramount. It makes our AI systems not only easier to understand and debug, but also highly maintainable and testable, which are critical principles for any production-ready software. So, what have we learned today? We've seen how a simple command line game can illuminate the core architectural patterns of complex AI systems. You've understood how classes define AI agents, how dictionaries store their knowledge, and how functions dictate their behaviors. These are the building blocks you'll use to create sophisticated applications. Now for a quick self-assessment. Can you explain how the concept of a Python class directly relates to maintaining separate contexts for multiple AI conversations?